Welcome to lesson 5.3, properties of squares and rectangles. Now I know you heard of these figures, and you kind of have an idea of what they look like, but we're about to go a little bit deeper into them and explain what exactly makes a Robertson square and what are their properties. You excited as I am? Good. Let's get on in. We're going to start with the properties of a rectangle, and these are the special properties. So to remind you, because these are parallelograms, all right, a rectangle is a parallelogram, it has all the properties of a parallelogram. That still remains, right? Opposite sides are congruent, opposite sides are parallel, opposite angles are congruent. You know what I'm talking about. So it has all the properties of a parallelogram, but then it has two special properties that, all right? Rectangles have two special properties, all of them. The two special properties are this. One, all angles are 90 degrees. Right? You've seen that. You know that in a rectangle, all the angles are 90 degrees. And another way that we might say that is that all angles are congruent. Now, these mean the same thing, of course. All angles are 90 degrees, so they're all congruent. But, you know, they can be referred to either way. So that's the first property. All angles are 90 degrees, also referred to as all angles are congruent. The second one, pretty straightforward. Diagonals are congruent. All right, so if we were to look at this guy, we would say that CB is congruent to AD because those are the diagonals. All right, so that is true for rectangles. Now don't confuse this with a rhombus. The rhombus, like a rhombus, the diagonals aren't congruent. In a parallelogram, the diagonals are congruent. If you looked at a picture, you'd see that. Only in a rectangle do you know that they are congruent. Okay, so let's do some example problems with this. First, in parallelogram YAPS, we know that YP is congruent to AS. So this whole thing is congruent to this whole thing, okay? These guys are congruent. How can I prove that this is a rectangle? Well, I know that parallelogram YAPS is a rectangle because, well, which property is this? Is it all angles are 90 or diagonals are congruent? I think you guessed it here. It's diagonals are congruent. So that tells me that this is a rectangle. If the diagonals are congruent, then I know that it's a rectangle because it has the properties of a rectangle. Let's look at another one. In parallelogram MNOP, we know that MN is perpendicular to NO. We want to prove that MNOP is a rectangle. Well, I'll show you this. So if I know one of the angles is 90 degrees, well, look at this. Since this is still a parallelogram, I know the opposite angle is 90. Right? And if I know that this is a parallelogram, I know consecutive angles have to add up to 180. So if this is 90, this is also 90. And if this is 90, well, the opposite angle is 90. So if one of the angles are 90 and it's a parallelogram, look at that. It's a rectangle. So parallelogram MNOP is a rectangle because all angles are 90 degrees. Another way to say that, they're all congruent. All right, we're getting it. We're looking good. All right, let's try this problem right here. MNOP is a rectangle. It's given that it's a rectangle, so I know it has all the properties of a rectangle. If POM, that's this angle right here, is 42 degrees, find the angle MNO. Okay, so we're looking for this guy right here. I'll put a little X there because we don't know it. Well, you might see right now that you have a triangle right here. All right. And if we have a triangle, if we know two of the angles, we can find the missing angle. Well, I know one angle. What's this angle right here? Look at that. It's 90 degrees. No way. So if I wanted to find PMO, I would just do 180 minus 90 minus 42, and that would give me 38 degrees. So angle PMO is equal to 38 degrees. See how we just used a property of of rectangles to solve this problem? It's pretty sweet. Loved it. That was great. Let's move on to squares. Okay. So in a square, this is the thing about a square. A square is basically if you took a rhombus and a rectangle and they made a baby. And what I mean by that is this. A square just has all the properties of a rhombus and it has all the properties of a rectangle. All right, so that's what makes something a square. It's actually something that's both has rhombus properties and a rectangle properties. All right, and you might intuitively know this, right? Let's start with the properties of a square that everyone knows. In a square, we know Well, let's mark this. Most obviously, you learn this all throughout your life, that a square, all sides are congruent, right? All sides are the same. And that's actually a rhombus property, right? That it stole. No one knew that it stole it, but it did. See, he's like a little rectangle rhombus baby. Now, the other thing you might know is that all the angles are 90 degrees in a square. And where did that property come from? Oh yeah, that property came from a rectangle. So we would say that all angles are 90 degrees. All right. Now it actually has all the properties of a rhombus and rectangle. Maybe you didn't learn those. These are the ones that most people learn in grade school and middle school, but it also has the rest of the rhombus and rectangle properties. So let's go over the rhombus properties. What else do we know about it? Well, we know, let's see, diagonals bisect, vertex angles. So if I had two diagonals here, I know those are poorly drawn. These two diagonals bisect these vertexes. And just to tell you this, since this is always 90, I know that these are both going to be 45 degrees. See, those are both 45 degrees because it bisects it everywhere. Doesn't matter where you go. These diagonals bisect, so they're all going to be 45. Now we also know that diagonals are perpendicular. So guess what? These are all 90 degrees as well. So this square has all the rhombus properties and it also has all the rectangle properties. So it has all angles are 90 degrees, and we also know the diagonals are congruent. We just learned that. So that's the thing about a square. It has all the properties. It has the square property, it has the rhombus properties, the rectangle properties, and it has the parallelogram properties. Whoa, that's pretty cool. Now let's talk about proving something's a square. All right? To prove something is a square, it has to have both one rectangle and one rhombus property. You have to prove that it's both a rectangle and a rhombus. All right, and I'll show you how it's done. In parallelogram ABCD, all sides are congruent. All right, so it tells me that all the sides are congruent. And I know that AC is congruent to DB. All right, so those are my two givens. I know that that's true. Now, first we have to prove that this is, let's say, a rhombus. Okay, we'll start with a rhombus. Well, I know that parallelogram is a square because, well, I'm going to have to prove that it's a rhombus and a square. Check it out. One, I know parallelogram is a square because all sides are congruent. Now I'm going to put a little note to myself here. I want you to put which property that is. That's a rhombus property. All right, always put that to yourself so you know. So I know it has the rhombus property. And now I need a rectangle property. And I also know that diagonals are congruent. And that's a rectangle property. So since it has a rhombus, I can prove that it's a rhombus, and I can prove that it's a rectangle. It has both properties. I know that this is a square. But it's got to have both, right? Because it is both. Now let's move on to another. Let's try another, okay? In parallelogram WXYZ, we know that WY is perpendicular to XZ. All right, so we know these diagonals are perpendicular. We also know WY is congruent to XZ. So we know these two diagonals are congruent. All right, how can I prove that this is a square? Remember, it needs to have one rhombus property and one rectangle property to prove. I got to prove that it's both a rhombus and a rectangle. So can I do that? Well, yeah, I can. First, let's prove that it's a rhombus. So parallelogram WXYZ is a rhombus because diagonals are perpendicular. Let's put a note to ourselves. We know that's a rhombus property. And we also know diagonals are congruent, and that is a rectangle property. Since we can prove that it's a rhombus and a rectangle, that makes it a square. Because remember, a square is just the little baby of a rhombus and rectangle. All right, and that's how we'd write out our proof there. For our final one, let's just find the missing angles. That's the next thing. We have to be able to do proofs in this unit. We have to find missing angles. Well, we talked a little bit about it when I was going over the properties, but let's find the missing angles here. In parallelogram ABCD is a square. So it's given that this is a square. Fill in the missing angles and state the properties used to find these angle measures. Sure, we could do that. The first one it says is find angle DAB. That's this whole angle over here. Well, guess what? Since we know that all angles are 90 degrees, we just know that this is going to be 90 degrees. Now, the reason I know that, well, that's the rectangle property. The reason I know that was 90 is because all angles are 90 degrees. Now, what is DAC? That's just this part right here. Well, that's 45 degrees, right? We said that earlier. This is 45, this is 45. And how did I know that was 45? Well, that's actually going back to a rhombus property, and that's diagonals bisect vertex angles. And then finally, it's asking me to find AED, which is right here. And I know once again that this is also 90 degrees. And how did I know that was 90 degrees? Well, we know that because that rhombus property again is diagonals are perpendicular. And that's why that's 90, right? These two diagonals are 90. I'm just going to put little notes here. You should probably put these yourself if you want to get good at this. This is a rhombus property. This is a rhombus property, which you can use because squares have those. And this is a what kind of property? Rectangle property. And since a square has all those properties, you can use them in finding these angles. All right, that's it for this lesson. It was a short one. So remember, with these extra 4 minutes that you have, go tell your mama that you love her, kiss her on the cheek, and say, hey, I'm cooking tonight. Shh.